As we continue to move across the viewport toolbar, the next thing I want to talk about are the 10 view modes that you have access to for each one of these viewports. Now, to give us a way to really see what these view modes are doing, we need to open up a level. So let's go to File, Open, and we'll choose VCTF Sandstorm, and click Open. Now, I'm just going to kind of start on the left-hand side and work my way to the right. If we mouse over each one of these objects, each one of these little buttons, you're going to see the name of the view mode. So there's Brush Wireframe, then Wireframe, Unlit, Lit, Lighting Only, Light Complexity, Texture Density, Shader Complexity, Light Map Density, and Lighting Only with Texel Density. So some of those sound a little bit complex. If you jump all the way back over to the viewport options, you can see each one of these here inside the menu, along with their corresponding hotkeys. So you can hit Alt 1 through 0, and you can select any one of these. Now, by default, here in the perspective view, we are in lit mode. This gives us lighting information as well as any material or texture information, allows us to really get an idea of what it is our level looks like. Now, the orthographic views, which surround our perspective view, by default, these are in brush wireframe mode. Now, if we take a look right next to brush wireframe, we have just regular wireframe. As we click between the two, you'll notice that the modes look very, very similar. And if you're completely new to UDK, it's very easy to get the two confused. Now, obviously, what these are going to do is just show you the wireframe of your level. So I'm going to go ahead and switch it on here inside perspective. And now we can see the polygon edges that are making up every single surface in our level, which is kind of nice. It allows us to really get an idea of our geometry. However, as I switch back and forth between wireframe and brush wireframe, the change that's going on is subtle, and I'd like to illustrate it by hiding a few objects. Let me take the perspective view, and I'm going to make it nice and big by clicking the Maximize Viewport button located at the far right-hand side of the viewport toolbar. Now, let's tap the W key, and what that's going to do is hide out any static meshes that we may have. I'm also going to tap the T key, and that's going to hide out any terrains that we might have. And if you have any volumes visible, you can hit the O key to make those disappear. So that's W, T, and O. Now, currently, I am in brush wireframe view, and you're going to see a lot of these shapes scattered across the level, like blue, interesting shapes. They're kind of like elongated boxes. These are BSP brushes. These are being used to define the shapes of various surfaces in our level. Now, I'm not going to go into any BSP creation techniques right now, but the more you start creating levels inside UDK, the more you're going to get used to how these brushes are created and their importance in a level. However, the engine itself during gameplay doesn't actually see these brushes. Each of these shapes, like if I select this BSP brush right here, which is now highlighted, this is an additive brush. All it's doing is defining an area of space with which mass will be added. Basically, it's going to create a polygon model in the shape of this volume. If we switch over to wireframe view, I'm just going to deselect our brush and switch over to regular wireframe, we can actually see the geometry that's being created as a result of that brush. Now, at this stage of the game, again, if you're completely new and you don't really understand the correlation between these two objects, it can be simplified a little bit. When you're in brush wireframe, you can select these brushes, and potentially, if you were so inclined, you could move them around. You could edit them, you could change their shape in geometry mode if you wanted to. However, inside of just regular wireframe mode, you can't select these brushes and you can't update them. So that's the real primary difference here. So let's go ahead and switch on to our next view, which is unlit. Now, unlit's going to look really sparse for a minute, so I need to bring back my static meshes. I'll do that by tapping the W key. I need to bring back my terrain, so I'll tap the T key, and I'll go ahead and leave the volumes out of the way, so I'm not going to worry about pressing the O key. Now, unlit is going to give us our texture, material information, but no lighting information whatsoever. It'll make the game look very flat, very much like games used to look several years ago. If we switch over to lit, the difference becomes obvious. So there's with our lighting information, and of course there's without. Now we can also take a look at lighting only. So we have unlit, then we have lit. We also have lighting only, which is kind of the opposite of unlit. This gives us our lighting information, but no texture or material information whatsoever. It's just the result of our lighting on kind of a neutral white surface. So if you want to see how our shadows are falling, you can get a really good idea of that sort of thing just by going to lighting only. Now, the next several view modes that we have access to here inside the viewport toolbar are kind of like diagnostic modes. They're ways that you can get an idea of certain performance issues in your map. The first of which is light complexity. And if you switch it on, in this particular case, nearly the entire level turns bright green, which is actually a good thing. What this mode allows you to do is visualize how many dynamic lights are affecting any given object. Green means they're only being affected by one light, which is what you want. As soon as any given object in your level is being affected by more than one dynamic light, you can start to run into performance issues. Now, that's not going to be something that'll be really important to you until you start playing a lot with lighting and creating dynamic lights. But for the time being, it's enough just to let you know what this does. If you see something like this where your whole level pretty much turns green, then essentially that's what you want. And unless there's a circumstance where you absolutely have to have multiple dynamic lights affecting an object, in which case that object will start to shift over to the warm spectrum, over through oranges and into red. Now, next to this, we have texture density. And this starts to look really cool. What this allows you to do is visualize how tightly packed the texture pixels of any given object are. So just as an example, let's pick on this stairway. So if we look at this in lit mode, you can see what it looks like. And let me go ahead and just kind of deselect it. So we got some stonework. It's got a nice normal map on it, which makes it look kind of chipped. Really, really nice weathered look. Now, if we switch back over to texture density, it's green. All right, and there are other things around here that are blue. This spectral shift is helping you to see how compressed any texture happens to be. As you shift over from blue to red, a texture is becoming much more tightly packed. If I rotate us around, we can take us to these ramps, and you'll see that these are starting to turn kind of orange. This means that the textures are much more packed here in these areas than they are over on any of the blue or green objects. As a matter of fact, if I select this object and we start to scale it down, which I'm going to do by grabbing the draw scale fields at the bottom of your screen here in the console bar, I'm going to take that first number and we're going to set that down to 0.5. And take a look at what happens. This object becomes a lot smaller, obviously, but it started to turn red. What that means is the same amount of texture is now covering a much smaller object, so the texture is getting much more tightly packed together. The reason that's important is that essentially this has just this exact same amount of texture information as does its larger counterpart. And you have to kind of start to gauge whether or not you really need that much information on so small of an object. Every single texture that you use is more memory that is required for your level. So if you have a lot of surfaces in your level that are turning orange or red, that means you probably have a lot more texture information than you really need on those objects. So that's really what that boils down to. Now if we switch over to shader complexity, we get yet another color scheme. This gives us feedback on how many shader instructions are in each material applied to the surfaces of our level. The green objects have a very low number of instructions, and the more instructions or the more complex that material gets, the color is going to shift over to the warm spectrum. So generally, you want to see green objects. Now, our terrain is red. That has a lot of different layers to give us various effects. If we switch over to lit mode, we've got kind of a primary material across the whole thing that's being blended through to show some rocks. There are several different things going on here. So that's going to be one of the more complex materials, just to kind of give you an idea of what you're looking at. Now, as we switch over from here, we have the light map density. Now, light maps are the way that baked lighting works inside your UDK levels. A lot of the lighting you see across the surface of a level is pre-calculated before the player ever sees the world. It allows things to be handled a lot more quickly when the player is actually running around if a lot of that lighting information is already pre-baked. This light information is stored inside what is called a light map, and you can get an overall idea of how dense your light maps are, meaning how much memory would be required to produce that light map using this system. So you can set up the ideal density, You can set up the maximum amount of density that you'd be willing to tolerate, which by default is set to 3, and then you're going to get some color coding to represent how dense your light maps are. Now, by default, in this particular level, the light maps are all pretty low, and it's a little hard to see which objects have tighter light maps, but you can see we have some objects here that obviously have much more dense light maps. If we switch back over to lit mode, we can see why. They've got some interesting lit properties about them, much smaller models. Now, if we switch back over to light map density, if we're just kind of having a hard time visualizing with everything being so dim, we can take our grayscale scale and increase that. And that's just kind of taking the overall output and boosting the contrast on it. Now, if we switch off render grayscale, we get color feedback here. And this is the same thing you were looking at before. No information has changed, but you start off with blue being your lowest level of density, and that's going to start shifting up to a warm spectrum. So if we take our color scale and increase that, we can already see that spectral shift starting to take place where certain objects are starting to shift over toward a bluish green. So that's a quick look at our light map density. Our last view mode is lighting only with texel density. Now this looks a lot like lighting only. As a matter of fact, let's just jump back over to lighting only, and you can see the difference between the two. And I can close the density rendering options window. We don't need that anymore. The difference is that lighting only with texel density allows you to see how compressed your textures are at the same time you're looking at your lighting information. And in this case, it's visualized through these checkers. The smaller these checkers, the tighter your texture is compressed. That's really all there is to it. That means you've got a lot more texture information crammed into a small space. Now, if you're unfamiliar with the term texel, it's just a combination of the word texture and the word pixel. So it's just a single texture pixel, or a pixel of any given texture is referred to as a texel. So that is a quick look at all of the different view modes. Most of these are really just diagnostic views to help you nail down and deal with performance problems in your level. The big players here are going to be your lit mode, which you'll be using a lot inside your perspective viewport. Just as a quick review, we have brush wireframe, which allows you to see your BSP brushes. Regular wireframe, which shows you the resultant geometry of your BSP brushes. We have unlit, which shows you your texture information but no lighting info. We have lit mode, which is just, it's the pretty version. We have lighting only, which doesn't show any of your textures. Light complexity, this gives you how many dynamic lights are affecting each individual object. Texture density, which is how tightly crammed your textures are on any given surface. Shader complexity, which is how many instructions are within any material on the surfaces of your objects. Light map density, which is how dense or how much memory is going to be required for all of the light maps in your level. And finally, lighting only with texel density, which is just a way of looking at your lighting information combined with how tightly compressed all of your textures are across the surfaces of your level. So that is going to wrap things up for this video. Thanks a lot.